So I think we should start. A warm welcome from my side. Simon and myself are really proud to present this topic. Now we are talking about, we have a webinar created for you about AI supported whole vehicle homologation for end-to-end traceability and faster compliance. This is the part one, the pre-webinar. May I jump to the next slide and say, Simon, Therese, and myself, Christoph Wolf, are doing this webinar. So I'm proud to hand over for the first introduction to Simon. Please give us a short overview about your experience.
Yeah, hello everybody. Nice to meet you. My name is Simon Terrace. I'm a solution manager for ADAS and AD at AVL for over 8 years now. And my focus was always on virtual or mixed reality testing. And for ADAS AD, of course, also focus on scenario-based testing with a clear goal to create sound and reliable evidence for validation and homologation of autonomous vehicles.
Many thanks for your introduction. So then from myself, my name is Christoph Wolf. I am an integration engineer for active safety since 6 years in AVL. I am focusing on ADAS ID requirements and homologation readiness, and also the translating the regulatory to the and NCAP requirements into optimized traceable test coverage based on data and also practical engineering experience. To start up with to end up with our introduction, maybe there's the first main sentence about, to summarize, our method what we now present is not absolutely necessary for a new initial approval, but if relatively frequented updates are planned, the method will be present really becomes really interesting for you. So this is also to say I can transmit the presentation to Simon. He won't give us a short overview about what is the challenge and how complex are the regulations in the future or now.
Thank you, Christoph. Maybe one small reminder also, if you have questions, something is unclear, or you want to drill down into something, you can anytime just use the chat, which should be here on the side on your screen. We will do a question and answer session at the end of this webinar, and then we will go through all these questions. So you can ask now, you can also ask later, and we're happy for every question you ask. If we look at the global landscape of software-defined vehicles with a focus on automated driving functions, we can cluster currently in 3 big markets. Plus, I want to mention India, I also see currently as a really booming market, which is not fully established yet. That's why I wanted to focus on these 3 big markets now. And I want to first start seeing, okay, what are the difference in these markets? And I can tell they all bring different challenges, but also different chances. If we look to the United States, we know it's a highly innovation-friendly market. A lot of startups are testing their automated vehicles there. We have also big leaders like Waymo with a lot of funding, implementing amazing level 4 autonomy. The market is also fragmented across states. So I mentioned Waymo. They are, for example, in California and Texas, but we don't have the same rules in the whole United States. And also, it's a bit tricky for smaller players because there's always a little risk involved, because the whole market works with the basis of self-certification and post-incident oversight. This means you can go quite easily on the road, but if something happens, you need to be ready that you will be sued for it. So you still need to make sure on your own that you are compliant and that you did the best to have a good safety argumentation and quality assurance. In Europe, if we look over there, over the Atlantic Ocean, it's a bit different. Europe thinks safety first, innovation second. So Europe really wants a very clear safety argumentation and a very clear type approval also before a vehicle can even go on the road. This is a very structured process. It's basically the homologation, which ends up in a type approval, which allows vehicles to be operated on the real roads, on public roads. What is really new or coming up more and more now is that Europe also has so-called multi-pillar approach allowed in the regulations. Multi-pillar means that you can test not only on the real roads, but you can also introduce virtual testing as a second, or yeah, if you say you have simulation as one pillar, but you can also have mixed reality testing like hardware in the loop or vehicle in the loop. This means you can bring in different test environments to make your safety argumentation and to also orchestrate your testing. And this is the future, and we're actually really happy that Europe brings the first regulations here. But also, this is, of course, an iterative approach. They are not fully detailed specified yet, and there is a bit of room for interpretation what is okay and what is not okay. Finally, if we look to China, it's a super strong market that has a mix of strong experimentation in different locations, but then at the same time also a quite strong central oversight, meaning different players, different OEMs also get some centralized support, like a global database that can be used and leveraged, which of course also helps to speed up innovation and development if there are some infrastructure shared between companies. At the same time, we know it's a very fast market. So the standards are also evolving there and they're changing quite fast. And we also see a strong increase of compliance requirements, especially for safety, but also for data. So we often hear from customers that data cannot leave China. So this also brings in new challenges. How do we work together globally? And also, how do we spread vehicles into the global market? At the same time, and I think everybody knows this by now, China is about speed. China is fast and China is strong. So I'm sure we will also see very interesting technologies coming from there in the future. Please, next slide. The biggest challenge that we see also together with our customers is the increasing compliance effort. If we look at this a bit like the iceberg in the water, we all know the tip only makes like 1/6 or something of the overall iceberg. So the majority part is underwater and you cannot see it immediately. And the same thing is actually the same thing with the regulations. So there are some regulations out there. Some of them are global, UNR. We also have some, for example, in Europe. And if you look at the documents, they don't change too much by length. All of them are between 10 and 30 pages long. But what it means to implement this in a compliant way in your homologation process, this is actually increasing exponentially. We have here, for example, on the left side, the level 0 function, an emergency brake assist. So it only would give you a warning. It wouldn't even interfere with your vehicle. That's why it's a level 0 function. It's quite easy to test. You can do this on a proving ground and you're done. If we look into level 2 plus, which most of the industry is doing right now, some call it level 2 plus plus already, where we have longitudinal and lateral systems mixed together. And the vehicle is more or less capable of driving autonomously, but the driver needs to be monitoring all the time. This is basically the UNR 171 or the DCAS, it's also called short. We already see a big increase because we cannot do this on the proving ground anymore. We also need to implement new strategies like SOTIF, which doesn't give you a clear list of you have to do 100 or 1,000 tests and you're done. It already makes it more difficult to tackle how can I do now a sound safety argumentation and how can I prove that I did enough. And same challenges, of course, for level 4 and even stronger. We have a regulation in Europe for level 4 driving since 2022. And we are expecting a global regulation, the UNR for ADS. It should come in June this year, but you know how it is. And of course, there for a full level 4 system, this is also being even more effort to implement a full compliant homologation process for this. Please, next slide. One of the core principles that we see in the software-defined vehicle market, but especially also in the automated driving market, is that we need fast cycles. With cycles, I mean update cycles, innovation, and improvement cycles. This is really, that's why I also show it here as a DevOps. This is a process you have to go through multiple times. Every time there is something changed, and this can be, of course, a new feature set in your ADAS system. You improved something, you want to release this to your customers, to roll it out to the fleet. But it can also be other factors. We see it here on the left side that there is, of course, the target operational domain. This means if I want to expand to, for example, my feature also working in other countries or on different types of roads, again, I need to go through this whole cycle. Also, regulations can change. We saw this with DCAS. There's already a revision 2 out, which introduced some changes. And then, of course, it also needs a rehomologation to make sure you are also compliant to this new version. And finally, also, there's a lot of market differentiators you can bring in to exceed the expectations given by the regulations so that you have an even better system than the competition. All of this ends up in requirements, and we go to the typical DevOps loop. We have a development, then we have the verification and validation. Important here, we do this in a multi-pillar approach, meaning testing on different test environments. And then comes the tricky part. We need to go through the homologation process and get our type approval. This is especially, of course, important in Europe, but of course, also in other markets, there is a type of compliance you need to fulfill. I mentioned in US, there's a self-certification, so you do it for yourself. There's not a third-party auditor checking this. And of course, in China, we also have new regulations coming. So this is really a challenge everybody is facing right now. How can we make this process fast? It's a lot of documentation effort, a lot of reviewing effort, and you really need to make sure that you have this safe and sound because otherwise it's a legal risk. Once this thing is taken, of course, we're good to go. We can roll out this feature to the fleet. We do an OTA update, and then we do fleet monitoring and incident reporting. So we check how is this new version performing? Do we have some problems still there? These are reported back. We analyze them and we define requirements to improve. That's the typical cycle. I think everybody knows this. The key challenge here, and that's why it's marked red, is to go through this compliance phase. For many people, this is currently a bottleneck. It is okay to do this once, to say we have a DCAS system, we want to have a approval once, but there's not a real solution yet or a real standardized process how to do this, for example, on a monthly basis. And there's even more challenges coming up. For example, if we have AI stacks that are modular AI or even end-to-end stacks, there needs to be new rules also. How can they be homologated? The technical services also need support here. How can this be defined? At the same time, this is I think everybody will face this now, and we will see the market changing. We will see a change here in how the processes are, how the standards are, and we will see multi-pillar coming as a key concept for a homologation evidence creation. Can you please do the next slide? I want to go now, what is AVL's role in all of this? So what is AVL doing, and why are we doing this? And why do we believe we can do this? AVL, to sum it up, we see ourselves in the role of a facilitator. We work together with OEMs, but we also work together with technical service and authorities, and we have a wide global network that allows us to bridge the gap here, to introduce these new processes, also bring in new tools that support it, to speed up this process. The main focus of this arrow is, of course, now to go through this validation to homologation phase. Of course, AVL as a company with over 10,000 employees worldwide, we also have services where we can support in the rest of this process. So, of course, we also have solutions to do the fleet monitoring and incident reporting in a compliant way, and how to bring this back to a requirement management system, for example, Codebeamer, to have this also fully traceable. The core thing that we want to enable here is speed. We want to bridge the gap. We want to make processes work faster and smoother so that it is possible to do updates even on a monthly basis. And this is basically the value pitch or the idea, the vision that I want to show you. And now I want to give over to Christoph to explain you what is necessary to do this and how can it be done.
Many thanks for the challenge introduction. Now we are taking over. I will take over and want to give you a brief overview about from our method, making from regulation complexity to an audit ready evidence. So First of all, I have started more or less from a regulation complexity to audit-ready evidence. Our focus is more or less on the left side, you see the current fragmented documents and silos, which are not directly perfectly linked together. That means the OEM homologation evidence is often dispersed across documents and requirements tools with limited linkage, which can make it difficult to show that all DCAS requirements are met end to end. This is the reason why we have thought about this current status and what is our approach. The AVL approach is that we structure the complete homologation evidence data for the fast homologation updates and also enabling rapid update cycles. This is more or less the main motivation that we see we have unstructured data, or maybe some requirements for sure are saved in requirements tools. Then the V&V team has some test reports on their side, and there is the homologation expert responsibility, and everybody who is involved in this process must give his input and output, but it's not really traceable linked together. And our approach is really to link the complete artifacts together in a traceable manner. And this is more or less an example of a real test catalog about an EU and China lateral ADAS feature for the homologation evidence. So with such an approach, it's quite easy and fast to show what is the impact and what must be considered in the future if there is an update. So to say, we can sum up: to ensure the homologation process is not a bottleneck, we have the target vision. Our target vision is that the type approval with end-to-end traceability regulation to evidence. We think about a backbone that enables a single source of truth. And for sure, we're making AI webinar. So AI is supporting us in the fragmentation, in the attribution, in also in the change impact analysis to create smart requirements and also make a test derivation, but only as a supporting manner. That means AI supports or suggested, then the engineers confirms and approves. And how we make this reliable? We have a governance, a quality assurance workflow, an audit trail, and also a traceable automation to do this manner. And the next slide, I want to go a little bit deeper in what we think about traceability essentials, the digital thread, we call it. And we make regulation computable and traceable by turning legal text into linked requirements and connecting them to verification and evidence. So if we talk about the left side, we have, first of all, is on an example. It's the market EU. It is only an example. It's the GSR 2021-646 ELKS regulation. Out of this regulation, we have extracted the fragments, more or less paragraphs, and out of these fragments, we have created smart requirements, system requirements. And you see there is a 1 to n relation. So that means it can be possible that one paragraph has multiple smart requirements. And this is quite important because in some paragraphs of the regulations are not really testable requirements because there are some mixed up. And then this is the reason why we have split it up into testable requirements. The next step, what I've mentioned, is the verification is explicit. So we have created out of the regulation some test groups, which is described in the regulation. And also the ODD is defined in the regulation. So therefore we have created test cases. That means the test group is overall the description with the ODD, and the test case is a specific test case. And also we can map the pass and fail criteria or status to this requirement, to this test group. And now our approach is every change propagates along the links. So we have to link the left side of the requirements to the right side to the test results to say how high is the test coverage. Why the edge nodes? So for the introduction, this point is a node, and the link between, I call it edge, Um, the graph, I think it is used from computer science. It is a graph, more or less this relation. So a node are governed items, which example, regulation fragments, requirements, tests, result, evidence. The edges are the type of the links. And this is how we answer the auditor questions like, why does this plan satisfy homologation? And how we do the impact analysis when anything is changes, because now we have a traceability to show this. And also, if something is changed, because the edges are typed, every change is propagates along the thread. It's quite easily to show which impact has a failed test result on the left side on the requirement side. And also, it's quite important, the AI is assisted fragmentation and impact suggestions, and engineering and homologation experts are approving these suggestions. Exactly. To go also one step deeper, there's one example to show the best practice, how we have created some prompt engineering about the smart requirements and also test case linkage. We say AI supported requirements extraction. We take a PDF, then also supervised from an engineer or from an AI plus supervised from an engineer. We create some structured requirements out of that. First step is to take the PDF, then we take the fragments out of that, and then we can derive smart requirements. We are using common LLM based tools. I think the solution is not new. A lot of many AA solutions therefore exist, but it's quite important to get to know why you are doing this and get experience, and also to get the experience to prove the outputs of the AI so that you can completely trust it and also rework it and make it reliable. Um, and also these outputs, more or less this must be aligned with further stakeholder requirements, for example, with some NCAP requirements or in-house requirements. AVL can also support on this. But the result is reduced ambiguity, faster verification planning, and also audit-ready traceability. This is the main output of our prompt AI-supported requirements extraction. In the next slide, sorry for a lot of text, but I think it's important that not only some keywords are mentioning. I want to really to highlight that we are thinking about how we are using AI, not really that we make it traceability, how we are using AI. We're making AI outputs reliable and audit ready. And AI is used to accelerate the work, not to bypass engineering responsibility. And therefore, our state-of-the-art AI prompt engineering structured outputs, we are extracting and taking recommendations. Then also we have implemented a confidence scoring and linking to the original rationale. Then for sure it can be calculated a coverage check. Is everything in what we have extracted? Also important, and I have it sometimes highlighted, is the human in the loop gates. So homologation and feature owners confirm critical updates. They have to confirm everything more or less. And also compliance and the audit trail. We have considered the EU AI Act. So every AI supported change is also versioned and traceable, stored. And the result out of that is faster processing with maintained correctness, transparency, and accountability. Exactly. This is more or less the deep dive of our AI approach. In the next slide, I want to highlight what Simon has mentioned, the role of AVL as a facilitator. So this means how AVL facilitates in the software-defined vehicle AD homologation process. We make homologation collaborative by turning regulations into shared traceable language and also audit-ready evidence. So what does facilitator mean? We translate regulatory into clear own requirements and test intents with both OEM teams and also the authorities can align on. So we structure the evidence into a single governance thread: regulation, requirement, test, result, evidence. So rational is transparent. And also we accelerate with transparency. AI assists our fragmentation and impact analysis. Humans review and also approve with a 4I principle. So no black box, full audit trail. What is changing for our customers or clients? Faster cycles. Rapid feature updates can trigger a managed homologation workflow instead of restarting from scratch. Fewer clarification loops with the technical service and authorities because each claim is linked to evidence and ownership. The tool or the method: agnostic integration. We connect to your requirements models or via an API with the test and simulation results from your systems. We don't force a rip and replace. So we accelerate the process without compromising compliance. Exactly. For the next, so now we know how is AVL using AI and what's more or less the role of AVL to support our customers. And now the next step is I want to talk about the backbone and also the linkage of the different artifacts. The backbone and the governance, the single source of truth. So I think the neutral spine of homologation, not another tool to replace yours, but the governance layer that connects regulation to evidence and also quality. And this should be no an AI black box. So we can say the backbones unifies regulation fragments, derived legal requirements, product requirements, test results, evidence into a governed thread, each item owned, typed, and linked. And it's where traceability lives, really focusing on traceability. And we can extract the linkage from each artifact together. Then also we are thinking about every update leaves a timestamp, explainable record. So who changed what and why. So we can compare deltas, roll back if needed, and also export audit ready packages without hunting across silos. For sure, every requirements tool, for example, CodeBeamer or example, Integrity, can also be there is locked. You can make some baselines and compare it. But the really benefit is to have an open backbone, which we can source or fetch information from the different requirements tool, bring it together with the testing teams across independently, rich supplier, mix it up and make one central traceability thread out of every items. And also for sure the 4 I's principle and release guides, so human in the loop. The AI accelerates the suggestions and humans approve. So the release guides freeze baselines at the key milestone, ensuring that monthly updates or rapid updates, over the air updates, or feature drops not to outpace the governance. So this is more or less explained what we understand as a backbone. And this is only, I think, one small screenshot out of this. We have regulation fragments, derived legal requirements. Then we go the next step, it's sub feature and also to the main feature requirements. Then we have also mentioned some component requirements and also simulation and test results. In this slide, doesn't matter, is it a test result from a proving ground or real world? It's only one box. And also we can extend this dimensional structure with a lot of other items and also logs. Now it's also quite important to mention the rules in this process. To clarity speeds the decisions. So we have, for example, the homologation responsible owns applicability and legal interpretation. They confirm that derived requirements correctly reflect the regulation and approve the changes. This is the anchor that keeps AI recommendations legally meaningful. Then we have the level O feature owner, owns the functional impact and the corrective actions when AVL solution flags deltas or test violations. This rule decides what to change and triggers the revalidation, turning detecting into accountability work. Then we have the system and the component owner, owns the implementation and the verification readiness. They translate the decision into software and hardware changes and ensure the system is ready to be tested again. And also for sure, the test and validation owns the test catalog, the execution, and also the evidence artifacts to make the test updates real, capture the results, and ensures the evidence is reproducible. So, um, and also quite important is collaboration with authorities and technical service. Clear roles reduce clarification loop. Each compliance claim has a named approver, each change has a review log, and each evidence package has a traceable origin, which makes conversation with authorities shorter, clearer, and better arguable. And for sure, our role of the thumb, AI support with recommendations, engineers confirm, and system proofs. So, and now I've take these two slides to show you the big picture or one screenshot shot out of this big picture, because it's not possible to show everything in one PowerPoint slide. We can say, and also this slide is highlighting the linkage of the different artifacts and owners. So we have the regulation fragments. It's also linked to the homologation responsibilities, to the feature owner. And at the end, it makes you full traceable via single source of truth, optimized evidence creation, a documentation, and also linkage to the regulations. It enables the traceability and also from legislation change to features, system component requirements, and recommends test cases and also corrective actions to ensure the vehicle homologation. You see it also we have on the right side, there is more or less a timeline about the approval and the release. And this should give you a first overview. Now I've prepared one example about an use case. What we are thinking is quite informative to show what can do this, our method. End-to-end regulation change, we have detected a modified fragment. That means one regulation has an update and now one paragraph is new or updated. Therefore, we can suggest for the adjustments and to the derived legal requirements. We can make an impact across features, system components, and also to the affected test groups. We can do on the system will do notifications, and we can do a review and also with for IS approval. Then we can do update the evidence and also release the decision what we have done and why. And our benefit is to enable an agile homologation updates with faster turnarounds, minimize clarification loops, and also audit-ready confidence. And to sum up, we automatically detect the regulation deltas, suggest the updates, and also derive the legal requirements, mapping impact across features, system, components, test groups. And this leads us to enabling exactly the benefit and fast agile homologation updates for the future. So now this is more or less the first use case. Now on our picture, you see the regulation is changed. For sure, the fragment regulation is also changed. So this means the homologation responsible must be notified that there's an update. And also it goes directly to the feature owner and about the sub-feature to this system component owner and also to the validation team. So we can say from, sorry. From a homologation perspective, each regulation delta immediately changes what must be proven. So it redefines applicable legal requirements. Responsible owners impacted features, system, and test groups directly affected evidence readiness and release timing. So why the rule of clarity is essential. Single source of truth needs single points of responsibility. AI can surface deltas, propose derivations, and map impacts, but humans must own applicability, acceptance, and release decisions. Without explicit owners, we get diffusion of responsibilities and also an audit gaps. Human in the loop is only effective when the loop is defined. So the four eyes principle approves and baselining depending on knowing who confirms what. Otherwise, AI suggestions become more noise rather than the governance change. And our answer, traceability equals answerability. When authorities or technical service ask, why does this plan satisfy the regulation? We must show not only the links regulation to requirements test evidence, but also provide the argumentation why this is sufficient and that relevant steps has to be approved. By quantifying the impact upfront, surfacing change fragments, link the requirements test, the reruns, the audit elements to the update, we convert a potential rehomologation delay into a governance fast path to an audible release decision. This is the main motivation. Now it comes to my last slide of this webinar, the AVL value proposition and also our Q&A time. We as an AVL are a facilitator for fast and compliant market entry and also lifetime compliance. We have regulatory expertise embedded in our ADAS-ID, in your ADAS-ID development. We have validation tool chains designed for compliance from the start. We have software solutions maintaining continuously traceability, and your partner supporting you along the whole homologation process. Yeah, on the right side, you see some engineering tooling facilitates. It does not mean only software solution. For ADAS-ID, we have also in Hungary, in Salazon, a really big proving ground to prove also the correlation of simulation with the real world or the proving ground testing. I will also highlight the topics that meet us at the Tech.AD in Berlin in March 23 up to 24. And also we have my colleague Simon has the second part of this webinar on April 2026. Great. I
Thank you.
thank you for your audience and thank you.
Uh, Christoph, thank you. That was really a lot of information, and I think it was a great view under the water to see the big part of the iceberg. What do you have to know? What do you have to consider? And what do you have to do in order to be fully compliant? And I'm sure this is a lot to digest. And I would also like to suggest here, if you want to go in a deeper discussion with us, feel free to reach out anytime. And then we can also make directly one-on-one meetings. You can have the chance here to get a discussion with our experts. Let this be like a teaser, an overview. But of course, we can always discuss this for any individual use case. I want to remind you also, we can do the question and answer session now. We're still waiting for questions in the chat, so please don't be shy. Feel free to ask question if anything is unclear. I would have one question to you, Christoph, because when you explained the use case where you show, okay, a regulation changes and you can trace through the whole data thread, what has changed? This means I showed in the beginning that for every change you have to go through the whole DevOps cycle, you have to do the whole homologation again. But I think it means you don't have to do the whole homologation, right? If you do it smart, you can really do this delta analysis, I think you called it, and know, okay, I only need to test a subset now, and a subset evidence is enough if I can trace back and prove that also only a subset of my requirements have changed. Maybe can you explain this again? Because I think this is a very crucial point here, right?
For sure. And this is, I think, also the main, yeah, traceability. If we are linking every requirement to the complete test evidence on a quite detailed level, so we can really easily highlight which impact has a violation of a KPI or has the update of the regulation, and which tests must be retested. For sure, there are some general tests, because if you are thinking, if you have an AI stack and you change a minor piece of code in there, or the perception is a little bit changing, it can be that the complete system must be tested to make to get sure that the system is running just like before. But to highlight it, it is easy to highlight the difference. What is the impact of the from the regulation to the test side, and also vice versa? So yeah, to show this really in detail and answer this question in a perfect manner, I think we need a deep dive. And yeah, but it is possible to really highlight only this, because of this situation, this and
Mhm.
that requirements are changed, and vice versa. So you don't have to retest everything. You can only say this with this update or this new feature behavior has an influence to this and this requirement, and therefore we have tested a selected amount of test groups or test cases to get safe and confident and validate the system that it runs safe. Hopefully I've answered your question.
Yeah, of course, you answered it. I think I just wanted to make it more clear again how crucial this point is, that we have here a chance to not do a full blown homologation every time there is a little update. That with this methodology, it's really more faster and, of course, way more efficient, and in the end, also less cost. I would have one more question to you. I know you are working with many different OEMs globally, and I think you could really tell, where do you feel the biggest compliance friction today?
Okay. I think the biggest friction comes from not really perfect linked evidence and unclear ownerships at the change time. When a regulation changes or a test violates a KPI, we spend time finding what's the impact of the requirements of the owner and exact evidence to the update. So rather than acting. But that's why we focus on single source of truth with explicit links, regulation, requirements, test evidence, and the governance rules. So it turns search work into decision work. So in sum up, the friction is unlinked evidence and also fuzzy ownership. The solution is the governance graph and also clear roles of who is responsible for what.
That totally makes sense to me. I have one more question here. Um, if you could automate just one step in your homologation workflow using AI, which one would you pick, and also why would you pick it?
Um, okay, I would say, so for sure, for an person who has done his first ADAS experience as an VNV engineer, I would say personally from the VNV side. But I think it's important to say the regulation delta. We should pick this and make great impact analysis, because then we can detect the changes of the fragments and also propose updates for the derived legal requirements, and also map the impact to the feature system components and the effect. What is the effect of the test groups? So because this unblocks everything else. So if I know what are the gap, then I can make measurements to fill up the gap. Yeah. And also to sum up, automate the impact analysis first, and then converts change into a governance and also repeatable flow. So find out what you have to do, exactly, and then link it to the test. Because if you know what is the change, then you can, if our method traceable, link it to everything what you have. And this is also possible to say, I think it was not directly in our presentation, but with this data set, we can use it and say and compare loop 1 or homologation update 1 with homologation update 2. What are the differences and how long it takes to get the regulation change to a complete test group?
Mhm.
And for sure, in the big data, or I would say in the AI agentic time, if we have precise, well-structured data, the output of every agent will be much, much better. So it's maybe not linear, it's really exponential. If you have well-designed data, the answers and the response of the LLM which will be much, much better, because you can also define the guardrails. So what you expect exactly want and also the rules. Yeah.
Thanks a lot. This sounds like you made a lot of thought about this already, and I'm
Yes.
sure we will see this soon. We have one more question coming in from the audience. Thanks for the presentation. Do you have an actual real world example where it worked out to accelerate homologation with an OEM? If yes, how much did you reduce the time from general homologation timeframe of several months? Thanks.
Exactly. It is more or less, and I would say it. So the complete method for sure developed during an R&D project in the AVL, but we have used it for, it calls, every year it comes a new, more or less, slide homologation about this ADAS lateral features. And there are some updates, for example, of the UNR 79, and this has a crucial impact of the current test catalog. This is the reason why we have designed this complete method, to show what is the impact out of that, and how the V&V engineers can prove and give the new evidence package to the authorities. And the complete process to identify the real responsible engineers and approve that they can say, okay, this and this was a KPI violation, we have to do this and that. To be, to make an estimation, I would say without the complete traceable process and with the new process, I think it's, yeah, up to 40% faster. Yeah, if we say, and also it is still possible to say, if you derive the complete legal requirements into smart requirements by hand, it's really time consuming. And if the AI just suggested you some requirements which you can rework and approve it as a human, it reduced the effort, but the complete process more or less 40%. And also, not only the time is measuring, you get quite confident data, and you can really structured show the homologation authorities what you have done and why you have done this and that. So the awareness of the changes and the updates is much, much higher. So this is also a benefit, but it's maybe not that easy to say as a, to calculate it in money. But yeah, you're faster, more or less 40% for my previous project as my experience, and also the complete traceability of everything what we have done in one click to show, or in 2 clicks. It depends.
Thank you very much, Christoph. Maybe I can also quickly comment on this, saying I know we're implementing parts of this already with OEMs worldwide, mainly, of course, for Europe homologation, where it's the strictest or strongest homologated market, regulated market. At the same time, the method we presented today, I think I mentioned it also in the introduction, we see this as a complete paradigm shift. And this doesn't only require the OEM to play, it also requires the technical services to adapt. And Christoph mentioned already, we introduced this new structured way of providing the whole evidence and the whole documentation, which will drastically speed up the way how this can be reviewed and approved. So the idea is really we're doing parts of this already in the last years, using all this experience, we want to bring homologation process to the next generation. And of course, this will take a bit of time in the market to be adapted from all players, but we believe this is the only way to come to rapid update cycles. If we talk about, let's say, monthly OTA updates that are homologation relevant, we believe that's the only way. And we are doing our best to facilitate this on all ends using our network with different partners. I didn't get more questions in the chat. So I would say let's close the session. Again, one last, if you have more questions, they come up later. Feel free to always reach out to us. You will find our contact information easily. You can also find us on LinkedIn. I would be happy to have any kind of discussion. And I was also very happy to have this webinar with you, everybody. So thanks for your attention and hope to see you at Tech.AD or also in the next webinar in April.
Also, many thanks from my side for your attendance. I wish you a nice weekend. We see us or hear us on the next Tech.AD and our next webinar. Thank you.
Bye.